I'm going to explain about the introduction for this video. First of all, acid-base titration and neutralization. This titration is used to determine the unknown concentration in a certain substance with one of the concentration is already well known. At the end of the titration, the color change from the result observed, the indicator, the pH meter and the electrical conductivity can be known as a neutralization process. This process can be used and applied in many aspects and concepts. Next, what is neutralizing wastewater? Acid-base titration concept is used to neutralize the wastewater that contain volatile fatty acid. By using the titration of the acid and base concept, the problem of wastewater can be solved. Three examples of neutralizing wastewater aside from titration of an acid base are steam distillation, titrometric method, and chromatography.
And now I want to discuss about application in water treatment. This process began by determining the type and concentration of the acid or base present in the wastewater through titration with a standard base or acid solution. And then the precise amount of neutralizing agent is needed, such as sodium hydroxide and sulfuric acid. The neutralizing agent is then added to wastewater, causing an acid-base reaction that produces a side and water. And then, during the titration, the pH of the solution is closely monitored to determine the equivalence point where the acid and base are completely neutralized. The pH at this point will depend on the strength of the acid and base involved. If needed, additional neutralizing agent can be added to adjust the pH further into the desired neutral range. And then, after neutralization, any precipitate such or methyl hydroxide may need to be removed from the water through filtration before the treated water can be safely discharged. For example, water softening. In water softening procedure, acid and base are used to eliminate minerals that can lead to scale accumulation, such as calcium and magnesium. And another example is disinfection. Acidic chlorine compounds are frequently used to disinfect water by eradicating dangerous germs and diseases.
The next example is pH adjustment. Acids and bases are used to adjust the pH of water to optimal levels. For instance, acids like hydrochloric acid can be added to reduce pH, while bases like sodium hydroxide can be used to increase pH. Other than that is corrosion control. Acid-base chemistry is used to create a protective layer on pipes and infrastructure. It will prevent corrosion and ensuring the longevity of the water treatment system. The last example is flocculation. Acids and bases help in flocculation, where impurities in water clump together. It will make them easier to remove through filtration. This process involves the use of coagulants, which are often acidic or basic compounds.
Next, we will discuss about the methodology. The experiment is involved by titrating a water sample with standard sodium hydroxide solution. But before we start the experiment, we must collect the sample first. The water sample is taken from the river by using depth sampler. The sample is collected at the surface, middle, and at the bottom of the river. The objective of this experiment is to determine the acidity of water. The indicator we use for this experiment is phenolphthalein and methyl orange. The purpose we use this indicator is to determine the endpoint of our titration. The first procedure for this experiment is we need to prepare 0.1 molarity of sodium hydroxide. But before that, we need to know the amount of sodium hydroxide we need to use to prepare this solution. So by the calculation, we found that we need to weigh 4 grams of sodium hydroxide pellets by using analytical balance, and then we need to add small amount of distilled water to the 1 liter of volumetric flask, and then we need to stir the flask to dissolve the sodium hydroxide completely. And once sodium hydroxide is dissolved, fill the flask with distilled water up to 1 liter mark and mix the solution to make it more homogeneous. The second procedure is we need to measure 50 milliliter of water sample to the Erlenmeyer flask and add a few drops of phenolphthalein. The third procedure is titrate the sample with the standard sodium hydroxide solution until a faint pink color persists. Record the volume of sodium hydroxide used. The fourth procedure is add a few drops of methyl orange indicator. Continue titrating until the color changes from yellow to orange. The last procedure is calculate the acidity of the sample based on the total volume of sodium hydroxide used and the sample volume. The conclusion we can take from this experiment is the acidity of the sample is determined by the amount of sodium hydroxide used to neutralize the acids present. The phenolphthalein endpoint indicates the presence of strong acids, while methyl orange accounts for both strong and weak acids. The precautions are needed when handling the samples and reagents, as colored or turbid samples present of dissolved gases and interfering ions can affect the titration. The experiment provides a quantitative method to measure the acidity of water samples, which is important for water treatment and environmental monitoring.
Next is a conclusion. Volumetric analysis is widely used in the field of analytical chemistry to determine the concentration of various compounds in food, environmental, and pharmaceutical samples because it provides a precise and accurate method for determining the concentration of unknown solution. The method can be used in the various industries to ensure the quality of the products and to monitor the levels of pollutant in the environment.